Hello, and welcome to Boring History for Sleep. Tonight, we gently turn our attention to an object so ubiquitous, so fundamental to the modern consumer experience, yet so rarely contemplated that it might almost be considered invisible: the handle on a commercial refrigeration display case in an American grocery store. Have you ever considered the countless hands that have gripped these handles, the slight chill that permeates them, or the silent, persistent forces of engineering, economics, and evolving aesthetics that have shaped their very form? This unassuming point of contact, often taken for granted, possesses a surprisingly rich and detailed history, a narrative woven from the threads of material science, ergonomic principles, manufacturing innovation, and the subtle shifts in American retail culture over half a century. But to truly appreciate this humble interface, we must delve into its intricate origins and its subsequent incremental evolution. Our journey begins, perhaps somewhat counterintuitively, amidst the global conflict that defined the early 1940s. While the world grappled with profound geopolitical upheaval, the foundational elements for what would become the standardized commercial refrigeration display case handle were being laid, albeit under significant constraints. Prior to this tumultuous decade, commercial refrigeration in grocery stores was far less pervasive and standardized than it would later become. Many smaller grocers still relied on iceboxes or early, often bespoke, mechanical refrigeration units where doors were typically simple, robust affairs, sometimes resembling those found on domestic iceboxes, or even heavy wooden doors secured with substantial, visible latches and pull handles. These handles were generally designed for pure functionality and durability, often cast iron or heavy steel, sometimes with a nickel or chrome plating for rudimentary corrosion resistance and a touch of perceived cleanliness. The aesthetic was secondary, almost non-existent. Utility reigned supreme. As the 1940s dawned, the United States was transitioning from a period of economic depression into an era defined by wartime production. This shift had immediate and profound implications for the manufacturing sector, including those components destined for the nascent commercial refrigeration industry. Material shortages became a significant factor. Metals like brass, copper, and even certain grades of steel were redirected towards the war effort, leading manufacturers of civilian goods to adapt, innovate, or simply produce less. Consequently, the availability of materials for non-essential items, such as refrigerator door handles, was severely curtailed. This scarcity inadvertently pushed designers and engineers to focus on efficiency, simplicity, and the judicious use of whatever materials were accessible. In this environment, handle designs for commercial display cases, which were primarily focused on meat and dairy products in early supermarkets, tended to be straightforward. The most common form was a simple, solid bar handle, often cylindrical or slightly oval in cross-section, made from chrome-plated steel or, less frequently, a zinc alloy. Chrome plating, a process that deposits a thin layer of chromium onto a metal object, was valued for its relatively inexpensive aesthetic appeal, its moderate corrosion resistance, and its ease of cleaning. However, the quality of chrome plating could vary significantly, and during wartime, the priority was often quantity and basic functionality over long-term durability or flawless finish. These handles were typically surface-mounted, meaning they were attached directly to the exterior surface of the door with screws or bolts, often with exposed fasteners. The design was ergonomic in a very basic sense, a shape that could be easily gripped by a hand, allowing the user to apply the necessary force to open a usually heavy, insulated door, often against the resistance of a magnetic gasket or a simple mechanical latch. The material composition of these early 1940s handles was largely dictated by cost and availability. Steel, often low-carbon steel, formed the core. Its strength and relative abundance made it a natural choice. The chrome plating served not only an aesthetic purpose, providing a shiny, clean appearance that was desirable in food service environments, but also offered a degree of protection against rust and the corrosive effects of moisture and cleaning agents. However, if the plating was thin or damaged, the underlying steel would quickly corrode, leading to unsightly rust spots and potential hygiene concerns. Zinc alloys, sometimes referred to as pot metal, were also utilized, particularly for more complex shapes that could be economically die-cast. While initially shiny, zinc alloys were softer and more prone to pitting and wear over time, especially in high-traffic commercial settings. They were a compromise, a solution to material constraints. The manufacturing processes for these handles in the 1940s were relatively unsophisticated compared to later decades. Bar handles were often formed by bending and cutting steel rods, then grinding, polishing, and plating them. More intricate designs, if any, might involve simple stamping or casting. The emphasis was on robust construction that could withstand frequent use and the occasional rough handling inherent in a busy grocery store environment. Standardization, in the modern sense, was still nascent. While manufacturers might produce similar-looking handles, there was little overarching industry consensus on dimensions, mounting hole patterns, or material specifications beyond basic functional requirements. Each refrigeration unit manufacturer might specify their own handles, leading to a degree of variation across the market. As the war drew to a close and the economy pivoted back to civilian production in the latter half of the 1940s, a pent-up demand for consumer goods and infrastructure improvements began to drive innovation. The concept of the self-service supermarket, which had begun to emerge before the war, gained significant traction. This model necessitated display cases that were not only functional for refrigeration, but also aesthetically appealing and easy for customers to access. The transition from counter-service to self-service profoundly influenced the design requirements for these handles. No longer solely handled by store personnel, these interfaces now needed to be intuitive, comfortable, and durable enough for repeated use by a diverse public. Entering the 1950s, the American economic boom facilitated advancements across many industries, including commercial refrigeration. The rise of suburbia and the proliferation of chain supermarkets meant that display cases became larger, more numerous, and more integrated into the overall store design. The handles, naturally, began to evolve in subtle, yet significant ways. A key development in the 1950s was the increased adoption of stainless steel as a primary material for commercial refrigeration handles. Stainless steel, an alloy of steel with a minimum of 10.5% chromium, was known for its superior corrosion resistance, its inherent strength, and its sleek, hygienic appearance. Unlike chrome-plated steel, where the protective layer could be compromised, stainless steel offered protection throughout its entire thickness, making it ideal for environments prone to moisture, temperature fluctuations, and aggressive cleaning agents. The specific grades of stainless steel, such as 304 or 316, began to be specified, with 304 being a common choice for its balance of corrosion resistance, formability, and cost. While more expensive than plated steel or zinc alloys, the long-term durability and low maintenance requirements of stainless steel often justified the higher initial investment for commercial applications. Design aesthetics in the 1950s for commercial handles moved towards a slightly more refined, yet still utilitarian look. Bar handles remained prevalent, but they often became thicker, more substantial, and sometimes had more thoughtful ergonomic curves. Recessed pull handles, where the grip area was integrated into a depression in the door, also gained popularity. These designs offered a cleaner look, reduced protrusion from the door surface, and were less likely to catch on clothing or passing carts. The scoop, or finger pull, style became more common, particularly on lighter display doors. Some designs incorporated a slightly textured surface on the grip area, either through brushing or a knurling pattern, to improve tactile feel and prevent slipping, especially if hands were wet or cold. Manufacturing processes adapted to these material and design changes. Working with stainless steel required more specialized tooling and techniques than working with mild steel. Stamping, deep drawing, and welding became more precise. Polishing and brushing techniques for stainless steel evolved to create different finishes, such as the widely adopted satin or brushed finish, often designated as a number 4 finish, which diffused light, minimized the appearance of fingerprints, and was easy to clean. This contrasted with the shinier mirror finish, number 8, which, while elegant, showed smudges more readily and was more expensive to produce and maintain. The standardization movement also began to gather momentum in the 1950s. Industry organizations, recognizing the benefits of interoperability and common specifications, started to influence design. While full standardization of every handle dimension was still a long way off, there was an increasing expectation that components should meet certain performance benchmarks, particularly regarding durability, ease of cleaning, and resistance to environmental factors. The advent of self-closing door mechanisms, which became more common on display cases to maintain internal temperatures and reduce energy consumption, also influenced handle design. Handles needed to provide sufficient leverage to overcome the spring tension of these mechanisms, and they had to be robust enough to withstand the repeated stresses of opening and the often abrupt closing of the door. The early 1960s ushered in a new era characterized by accelerating technological change, particularly in the field of polymer chemistry. This decade witnessed a significant shift in material compositions for commercial refrigeration display case handles, with plastics beginning to play a more prominent role, either as standalone components or in combination with traditional metals. The post-war economic prosperity continued, fostering a climate of innovation and a desire for more diverse aesthetic options in retail environments. The plastic revolution of the 1960s introduced a range of new synthetic polymers that offered distinct advantages over metals in certain applications. Materials like ABS, acrylonitrile butadiene styrene, and PVC, polyvinyl chloride, became increasingly viable. ABS, known for its excellent impact resistance, toughness, and good aesthetic properties, could be easily molded into complex shapes through injection molding. This opened up entirely new design possibilities for handles that were previously difficult or costly to achieve with metal fabrication. Handles could now be designed with integrated finger grips, ergonomic contours, and even internal reinforcement structures, all in a single, lightweight molding process. PVC, while perhaps less common for the primary structural component of a handle due to its relative softness compared to ABS, found uses in gaskets, trim, and perhaps softer grip overlays. The integration of plastic elements into handle designs often served multiple purposes. Plastics were lighter than metals, reducing the overall weight of the door assembly. They were also thermally insulating, meaning they would not feel as cold to the touch as metal handles, enhancing the user experience. Furthermore, plastics offered a vast palette of colors, allowing for greater aesthetic integration with store branding or interior design schemes. While most handles remained functional and utilitarian, the option for color coordination or a more modern look began to influence choices. However, the widespread adoption of plastics was not without its nuances. Early plastics, while offering design freedom, sometimes lacked the long-term durability and scratch resistance of stainless steel, particularly in high-traffic areas. They could also be susceptible to degradation from UV light or certain harsh cleaning chemicals. Consequently, a hybrid approach often emerged. Manufacturers might use stainless steel for the primary structural bar of a handle, while incorporating molded plastic end caps, decorative inserts, or even ergonomic grip sleeves. This combined the strength and hygiene of stainless steel with the design versatility and thermal properties of plastics. Metal handles, primarily stainless steel, continued to be a strong presence in the 1960s, particularly for heavy-duty applications or where a premium, highly durable aesthetic was desired. The manufacturing processes for stainless steel handles continued to refine, with greater precision in stamping, bending, and welding. Powder coating, a finishing process that applies a dry powder, then cures it with heat, gained traction as an alternative to traditional liquid painting or plating for certain metal components. Powder coating offered a more durable, chip-resistant, and aesthetically versatile finish, expanding the range of colors and textures available for metal handles beyond the inherent sheen of stainless steel. Standardization efforts in the 1960s started to focus more on dimensions and mounting patterns. As display case models proliferated, manufacturers sought to simplify their component inventories. If a handle could be used across multiple models or even by multiple refrigeration manufacturers, it led to economies of scale. Industry bodies, such as the National Sanitation Foundation, NSF International, began to increasingly influence material choices and design features, emphasizing smooth, easily cleanable surfaces, minimal crevices where debris could accumulate, and resistance to degradation from sanitation procedures. These factors became increasingly important for handles, as they were high-touch surfaces in food environments. The trend towards self-closing doors continued, with handles needing to be robust enough to withstand constant pulling and the associated stresses. The internal mechanisms of these self-closing doors often involved torsion springs or hydraulic dampers, requiring a handle that could transmit significant force without flexing or breaking. The connection points between the handle and the door itself became critical, leading to advancements in hidden fasteners, reinforced mounting plates, and designs that distributed stress more effectively. Entering the 1970s, the landscape of commercial refrigeration handle design and material composition was shaped by a confluence of factors: the energy crisis, growing environmental awareness, heightened regulatory scrutiny, and a continued drive for efficiency and durability in an increasingly competitive retail sector. The flamboyant aesthetics of the late 1960s gave way to a more pragmatic and utilitarian design philosophy, driven by performance and compliance. The energy crisis of the early 1970s had a profound impact on refrigeration display case design. With rising energy costs, there was an intense focus on improving the thermal efficiency of display cases. This translated into better insulation, more effective door seals, and self-closing door mechanisms that ensured doors were not left ajar. Handle designs had to adapt to these improved sealing mechanisms. Tighter-fitting gaskets and stronger magnetic closures meant that handles often needed to be larger, more robust, and provide better leverage to open the doors. The pull bar handle, a substantial, often cylindrical or rectangular bar, saw renewed prominence because it offered a comfortable and effective grip for applying significant opening force. Regulatory oversight also intensified during this decade. The Occupational Safety and Health Administration, OSHA, in the United States, established in 1971, brought a greater focus on workplace safety, which implicitly influenced aspects of industrial design. While not directly regulating handle designs, OSHA's general safety requirements encouraged designs that minimized pinch points, sharp edges, and potential for injury. NSF International's standards continued to evolve, setting more stringent requirements for materials that came into contact with food or were in close proximity, emphasizing non-toxic, non-absorbent, and easily cleanable surfaces. This further cemented the preference for stainless steel and specific grades of durable, food-grade plastics. In terms of material compositions, the 1970s saw a refinement rather than a revolution. Stainless steel remained the gold standard for its unparalleled combination of hygiene, corrosion resistance, and strength. Manufacturers continued to optimize the grades used, often favoring 304L, low carbon, for welded components to prevent sensitization and intergranular corrosion, ensuring even greater longevity. The surface finishes remained primarily brushed or satin, as these were practical and easy to maintain in a busy grocery environment. Plastics continued their ascent, but with a greater emphasis on performance and durability. Early challenges with some plastics regarding scratch resistance or chemical degradation were addressed through the development of more advanced polymer formulations. High-density polyethylene, HDPE, polypropylene, PP, and improved grades of ABS became common for components where thermal insulation or design flexibility were paramount. These plastics were selected not just for their moldability, but for their resistance to common cleaning agents, their impact strength in cold temperatures, and their ability to withstand repeated use without cracking or becoming brittle. Molded plastic handles sometimes featured internal metal reinforcement, a hidden core of steel or aluminum, to provide extra structural integrity while still benefiting from the non-conductive and aesthetic qualities of the outer plastic shell. The manufacturing processes continued to advance. Automated stamping and bending machines for metal components became more precise. Injection molding of plastics achieved higher levels of accuracy and repeatability, allowing for tighter tolerances and more intricate features. The trend towards modular design gained further traction, where handles might be composed of a few standardized parts that could be easily assembled, replaced, or interchanged. This facilitated easier maintenance and repair for grocery store operators. Ergonomics, while not yet a formalized discipline in handle design, implicitly guided many choices. As the average supermarket grew in size and the frequency of door openings increased, the comfort and ease of use for both customers and store employees became more critical. Handles were designed to accommodate a wider range of hand sizes and gripping preferences, often featuring larger gripping areas and smoother transitions to prevent discomfort during repetitive actions. Recessed handles, while offering a sleek appearance, often needed careful consideration of depth and width to ensure easy access and a secure grip, especially when hands might be cold or carrying other items. The latter half of the 1970s also saw a subtle shift towards more blocky, angular designs in some industrial components, a reflection of the broader aesthetic trends of the era, moving away from the more fluid forms of the 1960s. Handle profiles sometimes became squarer or more rectangular, providing a robust, no-nonsense look that conveyed strength and reliability. The focus was firmly on function over excessive ornamentation, a response to the practical demands of an evolving retail landscape. As the calendar turned to the 1980s, the subtle evolution of commercial refrigeration display case door handles entered a phase characterized by increased material sophistication, a growing emphasis on refined ergonomics, the early influence of accessibility considerations, and the integration of new manufacturing technologies. The decade saw a push for greater efficiency, longevity, and a slightly more polished aesthetic, even for these utilitarian components. Material science continued its steady march forward. While stainless steel remained the cornerstone for high durability, hygienic applications, the specific alloys and finishes became more diverse. Higher grades of stainless steel, such as 316, sometimes found their way into handles destined for particularly harsh environments or for premium refrigeration lines, offering even greater resistance to chlorides and other corrosive agents found in certain cleaning chemicals. The options for surface finishes expanded beyond the standard brushed. Matte finishes, bead-blasted textures, and even specific non-directional polishes became available, offering subtle variations in appearance and tactile feel. These choices were often driven by a desire to match the overall aesthetic of new store designs, which were themselves becoming more sophisticated and branded. In the realm of plastics, the 1980s saw the widespread adoption of engineered polymers that offered significantly improved performance over their predecessors. Glass-filled nylon, for example, became a popular choice for handles or handle components due to its exceptional strength-to-weight ratio, rigidity, and resistance to abrasion and impact. The inclusion of glass fibers within the nylon matrix dramatically increased its tensile strength and stiffness, making it comparable to some metals in terms of structural integrity, while retaining the benefits of plastic, such as thermal insulation and design flexibility. Polycarbonate, known for its outstanding impact strength and transparency, though usually opaque in handle applications, also found niche uses, particularly where extreme robustness was required. These advanced polymers could be injection molded with even greater precision, allowing for intricate internal ribbing and reinforcement structures that further enhanced durability without adding excessive weight or material. Design evolution in the 1980s saw a move towards sleeker, more integrated profiles. Handles were increasingly designed to be flush or semi-flush with the door surface, contributing to a cleaner, more contemporary look. This was partly an aesthetic choice, but also had practical benefits. Reducing protrusions minimized the risk of accidental damage to the handle or injury to customers, and facilitated easier cleaning of the door surface. Modular designs became even more refined, allowing for quick and toolless replacement of certain handle components in some instances, streamlining maintenance operations for grocery store personnel. A significant, albeit nascent, influence on handle design during the 1980s was the growing awareness and advocacy for accessibility. While the Americans with Disabilities Act, ADA, would not be signed into law until 1990, The discussions and preliminary guidelines surrounding universal design and accessibility for people with disabilities began to permeate various industries. For refrigeration display case handles, this meant an early consideration of designs that were easier to grasp, pull, or operate for individuals with limited dexterity or strength. Lever-style handles, which required less grip strength than a traditional pull bar, started to appear more frequently, though they were still far from universal. Handles with larger surface areas, more generous finger clearances, and smooth continuous contours were implicitly favored as they offered a more inclusive user experience. Manufacturing processes benefited from the increasing sophistication of computer-aided design, CAD, and computer-aided manufacturing, CAM, technologies. While not as pervasive as in later decades, CAD software allowed designers to create and analyze handle prototypes virtually, optimizing shapes for ergonomics, material distribution, and manufacturing feasibility before physical tooling was created. CAM systems, in turn, allowed for more precise and efficient production of molds and dies, leading to higher quality parts and reduced manufacturing waste. This precision also allowed for the creation of more intricate and aesthetically pleasing textures on handle surfaces. Beyond simple brushing or polishing, the drive for energy efficiency continued to influence handle design indirectly. As refrigeration doors became even more tightly sealed, requiring greater force to overcome the gasket's resistance, handles needed to provide superior leverage and grip. This often led to longer pull bars or more ergonomically shaped handles that distributed the pulling force across a larger area of the hand, reducing strain. The self-closing mechanisms themselves became more sophisticated, with handles designed to withstand the often significant forces exerted by these mechanisms during hundreds or thousands of cycles each day. Throughout the 1980s, the standardization efforts by industry bodies like NSF International and Underwriters Laboratories, UL, became even more prescriptive. NSF standards continued to refine criteria for hygienic design, emphasizing materials that were inert, non-toxic, and easily sanitized, with seamless transitions and minimal crevices to prevent microbial growth. UL standards focused on electrical safety and performance, indirectly influencing components like handles if they were part of an electrically operated door mechanism or contained sensors. Compliance with these evolving standards became a crucial differentiator for manufacturers and a baseline expectation for grocery store operators. The commercial refrigeration display case door handle, by the close of the 1980s, had transformed from a purely utilitarian appendage of the 1940s into a subtly engineered component that balanced durability, hygiene, ergonomics, and aesthetic integration. The journey from simple chrome-plated steel bars to sophisticated stainless steel forms or advanced polymer moldings reflects not just advancements in material science and manufacturing, but also the broader societal shifts in consumer expectations, regulatory oversight, and the ever-present economic pressures to deliver reliable, efficient, and user-friendly products. The evolution of these handles, from the raw necessity of the post-war era to the nuanced design considerations of the late 20th century, truly underscores the principle of incremental refinement. Each decade introduced new materials, new manufacturing capabilities, and new pressures, whether from a booming economy, a plastic revolution, an energy crisis, or the nascent calls for universal accessibility. The shift from a purely functional object to one that subtly influences user experience and store aesthetics is a testament to the persistent, often unnoticed efforts of countless engineers, designers, and manufacturers. From the robust, straightforward chrome-plated steel bars of the 1940s, born of wartime necessity and an emerging self-service model, to the more refined, corrosion-resistant stainless steel and early plastic integrations of the 1950s and 1960s, mirroring the rise of the modern supermarket and a focus on cleanliness, each step was a response to evolving demands. The 1970s brought an emphasis on energy efficiency and stricter regulations, leading to more substantial, leverage-enhancing designs and an insistence on highly durable, easily sanitizable materials. Finally, the 1980s propelled these handles into an era of material sophistication, advanced ergonomics, and the initial subtle integration of accessibility principles shaped by computer-aided design and a broader understanding of the user. What began as a simple means to open a cold door gradually became a carefully considered interface, a point of continuous interaction that silently facilitated the daily commerce of millions. The subtle variations in a handle's radius, the specific grade of stainless steel, the choice of a glass-filled nylon over a standard ABS, the precise angle of a lever, or the texture of a grip are all the result of this half-century of quiet, persistent innovation. These seemingly minor details, often overlooked, collectively contribute to an object that, through its very unobtrusiveness and reliability, performs its vital function with unwavering consistency, allowing us to access the necessities and conveniences of modern life. It is a quiet testament to the pervasive influence of design and engineering on even the most mundane aspects of our daily existence.